So hi everyone. Good morning, good afternoon, good evening. I know we have people all around the world joining us for our fourth FHIR Meetup on the May 4th. And great audience today as usual. And thanks to everyone who is joining. Thanks for speakers who agreed to talk today about a very hot topic. So a couple of words about the FHIR meetups. We had them on and off for a few years, but we're trying to restart it again, and we want to make these events regular. So we invite everyone who is working with FHIR, developing solutions that use FHIR, to reach out to us, propose a topic, and we will try to have you at one of the next FHIR meetups. It's great to join what you're working on with the community. FHIR was always about the community, and I'm sure that there are a lot of interesting presentations that audience can present. So talking about today's topic. Today's topic is hard for many reasons. One of the reasons for US participants probably is new CMS and ONC rules, which require EHR systems and health systems and health plans to share data in the FHIR format with their patients to be compliant, and it requires testing, but not even for people involved into development of systems that has to be certified. FHIR testing is very important. I just read, I think in the beginning of April, there was a publication from Engine Group, which published that only 24% of healthcare organizations right now using API, and they predicted that FHIR will get significant traction. There will be widespread adoption only in 2024. But even nowadays, I mean, for this 24% of healthcare organizations to speak to each other and make sure that their solutions can really understand each other, testing is necessary. So that's one of the things what FHIR testing can solve for you. So we have three speakers today. One of the speaker is So for FHIR Meetup organization, so we'll have 2 hours. We'll have 3 presentations from 3 speakers. They will talk about their solutions and make demonstrations as well. And after each presentation, we will have a Q&A session. So please prepare your question, and you will be able to ask questions from the speakers. After the presentations, we will have a roundtable discussion, so all the speakers can discuss FHIR testing topic with each other. So please get ready to ask questions, and all your questions will be very welcome. Now, our first speaker is Rob Scanlon. He is a project lead for Inferno. He's with the company MITRE. MITRE is very famous for their open source FHIR solutions. Besides Inferno, they have also built another tool for testing FHIR, which is called Crucible. And many people probably from the audience saw and used the open source tool called Cynthia for synthetic data generation. Inferno is a very interesting project. That's a solution in particular allows testing of ONC Standardized API, and that's the application of FHIR testing, which I started with, which is about testing for compliance with ONC and CMS rules. So I want to pass the word to Rob.
Great, thanks so much. Let me see if I can just hop over and share my screen. Share. Can you guys see that? You good?
Yes, you can see it.
Great. Thank you, and thanks so much for having me. I'm really excited about this topic. My name is Rob Scanlon. As mentioned, I work for MITRE. I'm a software engineer. That's my background. I've been building software for a good 20 years or so professionally, with a big component of that being APIs and web APIs. Within MITRE, I've been the Inferno project leader for about, I think we've been going for about 2.5 years, so quite a while. And then prior to that, I was the co-principal investigator for the Crucible project, which was another FHIR testing project that was a internal MITRE research project. So whereas Inferno is sponsored by ONC, that's the Office of the National Coordinator for Health IT, and has a kind of a slightly different flavor of FHIR testing around, that was driven a lot based on the types of things that they're interested in testing. And my next button is, there we go. So today I don't have a lot of time. There's so much I think to talk about in this area, but I figured what I would do is just spend a little while talking about Inferno broadly and what it provides, and what we're trying to do with it. And the way that Inferno works is that you need to, it's a pretty generic test running system, but you still need to provide tests to run on top of it. So I'll talk a bit about the test suites that we currently have. I'll talk a bit about what goes into a test suite, and how you go about writing tests and generating tests based on existing machine readable sort of metadata. And then I just wanted to talk a little bit about some of the current challenges that we have, and just broadly what is hard for us in this area, because you know, I'm here to learn also, and I'd love to hear how other people are approaching some of the challenges associated with testing FHIR. So I'm going to share some of those as well. So really quickly, what is Inferno? So very broadly, it's an open source FHIR API testing tool. So we're focused on testing FHIR servers. We don't do, the current tool doesn't do, doesn't test FHIR clients, and it isn't really focused necessarily on just looking at sort of FHIR resources individually. We're really focused more on the FHIR API and the data that's sent along the API. This work is funded by ONC, and we started up basically as a way to put out a set of tests for ONC Standardized API certification criteria. So if you're not familiar with ONC here in the US, they have a certification program, which is part of an incentive program where essentially for providers that are working with like CMS and some of those programs, they want to use software that is certified by ONC, and so ONC sets a certain number of standards around that, and the most recent update to their rule involves a criteria for a FHIR-based API. That's focused really around the sort of a patient medical record use case, and enabling third-party apps that patients can use to be able to connect to their providers and get their data. And there are a number of other use cases sort of around it. So providing the ability for third-party apps to be embedded within sort of EHR kind of workflows that are practitioner facing. So that's part of it. Then also a way to send large quantities of standardized data between different institutions. That's sort of the bulk data aspect. So when they were putting out the rule for comment initially, they wanted to also put out a sort of a set of tests so that people can really see what the full requirements are, because it's a lot easier to tell what's required when you're looking at sort of the executable tests. And so, so we're providing those set of tests initially. And so if you want to get certified to that criteria, this is the tool that you use, although this doesn't necessarily have to be the only tool. It's just the first tool. And I hope other tools will come online in the future that you can certify against as well. Now this is, Inferno is developed and maintained by MITRE. As mentioned, we do a lot of work in the FHIR space. We do a lot of open source work. We're here to sort of work in the public interest, and a lot of the work we're doing is just trying to build useful tools to accelerate the adoption of standardized APIs and FHIR. So I'm thrilled that that we're able to build tools that are useful to this group, because I think everyone's doing really good work here, and it's really important. So what is what is basically Inferno? What does it sort of provide as a test system? There are a lot of different sort of ways that you can do testing. You can approach it a lot of different ways. What we've done is we've built basically a pretty generic testing framework that's very flexible, although it does have strong kind of bindings to FHIR. But when we were sort of starting to look at the requirements around what we needed to test, we realized pretty quickly a lot of it wasn't sort of pure FHIR. It was things like smart on FHIRs, app launch, and bulk data. And ONC had some other requirements around TLS sort of levels. So pretty early on, we decided to make just sort of build a fairly generic test platform that you can kind of test anything, and then add some, make it sort of easy to test FHIR as well. And so you'll sort of see that sort of throughout how this tool is designed. As far as FHIR itself goes, the tests, they come with a FHIR client. So it's a pretty kind of lightweight wrapper on top of a Ruby FHIR client, just a Ruby RESTful client. So you can basically make requests to servers pretty easily. We integrate. We have a FHIR validator running behind the scenes. You can either run. We have a sort of a native Ruby one, but we also integrate to the HL7 FHIR validator. It's actually the one that we encourage people. That sort of integration is the one we encourage people to use right now. It's the most fully featured. And we're also capable of doing terminology validation. And we also provide a pretty rich sort of assertion library, so you can pretty kind of succinctly, basically state that a certain request has to, in response, has to look in a certain way. We wanted to make this tool as easy to use as possible. I think, especially when it comes to the ONC certification criteria, it's really big. There's a lot of stuff to implement, and so we wanted to make the test tool as frictionless as possible, I guess might be one way of saying it. So we provide a web UI that's pretty easy to use. And if you want to do something a little bit more advanced, we provide a console UI, so you can sort of you can run all these tests outside of the web interface. Also, this is a sort of it's a downloadable tool. So this is all open source. We didn't want to have this just be kind of like a software as a service type thing that would be difficult for people to stand up behind their own firewalls. Because what we really want people to do is, prior to their APIs going live, they can run the tools themselves against their own test version. So you don't have to hook it up to the internet or anything like that. So you can run it behind your firewall. So that's sort of broadly what sort of Inferno is. I just have, instead of kind of walking through and pulling up the site, I just put together a couple of screenshots. It's pretty easy to use. If you just go to inferno.healthit.gov, you can hop into either the program certification tests, we call that the program edition, or you can run some of the additional tests pretty easily. On the certification tests, there is a little drop down. You can tell it to preset it with our own reference server that we stood up, and you can just kind of click through. But sort of briefly, this is sort of the this is the interface, right? So you just kind of you go into it. We tried to make it as kind of straightforward as possible, and have it be pretty opinionated about how you go about using the tool and running through the full set of requirements. So you don't have to sort of wonder what settings you have to sort of set in order to make this set of tests, do exactly what is required. Really, it's just, click a button, fill in some information, and then you go. So when you click on the run button, you just get, a lot of our tests have inputs that you have to put in besides just the FHIR endpoint. So this first set of tests has to do with testing the Smart App launch, and we require the demonstration of being able to support a confidential client. So you have a bunch of inputs. You click run, you get a bunch of results back. I think it's all pretty sort of straightforward, and what I think what people would expect when they are using a test system. We do provide a lot of information about everything that goes on behind the scenes, particularly all the requests and responses. So you can dig into that and see what happened. We also provide a lot of metadata associated with each of the tests to sort of explain what's going on in human readable terms. We're very mindful of the fact that the people running these tests aren't the same people that wrote the tests. So if you just get an error that's kind of opaque or hard to understand, that's not very helpful. So we try to provide helpful sort of error messages and also sort of describe everything that's going on behind the scenes. So for every one of our tests, you can click on there's a little about tab, and we describe exactly what's happening. So we provide, so Inferno is a test platform, and then you have to write tests on top of that. The first set of tests that we focused on were the ONC Standardized API certification tests. Call that right now we're calling that kind of the program edition, and it's packaged separately just to make it very clear that is the one that you would use for ONC program certification. But then we're also working towards making this as sort of broadly as useful a test platform as possible, and we're writing tests of various implementation guides. So part of the certification program involved Smart App launch, US Core, and Smart Bulk Data. So we kind of get those for free, but then now we're working in other implementation guides that have relevance, particularly in sort of the short term for ONC, but also we're kind of broadly interested in writing tests for any of the implementation guides out there that could use help. Now we're a pretty small team. There are just a handful of developers. So realistically, there's only so much we can do, but this is all open source, and I would love it if we could get some other folks using this platform to write tests as well. We'd be glad to sort of help anyone that is interested in doing that. Now, just to sort of highlight kind of what a large, sort of big involved test suite looks like. This is the one that I just showed you. This is the ONC Standardized API for Patient and Population Services. It's very complex. One of the things that drives the complexity here is that it is it's not just testing FHIR, but it's testing SMART on FHIR, and some additional ONC specific requirements around US CDI, which kind of puts some bounds on the parts of US Core that are tested. So we have all these kind of interesting interactions as far as making sure that if you launch an app with certain scopes, then later tests that are looking at sort of the content of requests and responses obey those scopes. So it's a kind of more of an integrated testing approach for all the different components, as opposed to say, just testing Smart on FHIR separately from US Core, separately from bulk data separately. One of the things that there's, when you're writing tests, there's a lot of ways of doing tests. We decided for this test suite that we would allow the systems under test to basically bring their own data. So I know a common way of testing systems is to provide a very specific reference set of data and say, okay, load all that up however you want to do that, and send it back. Because there's so much flexibility in the types of data elements that a system can support, we're instead doing something a little different, where we have the systems load up with their own test data. And then throughout the process of testing, we check to make sure that we've seen enough data to be confident that they're able to support everything that must be supported as required by US Core and ONC. So that's just one of those kind of decisions we made for this set of tests, although there's nothing specific about Inferno that would have you sort of write tests in that way. You can, if you'd rather, you can say, you can write tests that expect very specific data elements to come back with certain values. Another thing that we wanted Inferno to do is to be able to have a space if there are requirements that can't be tested in an automated way. So one of the steps near the end is basically a survey that asks the tester to attest to the fact that they saw certain things happen, and that the data that is being sent is actually the data that appears in the system that they're testing and whatnot. So it's sort of this was kind of a big effort to put all this together, but we really wanted something to be that we really wanted to provide something that was that was sort of kind of a one-stop shop for this, for testing all the requirements of this. Check the time. So on the other kind of end of the spectrum, we just recently put together some tests for the Smart Scheduling Links IG, which has to do with advertising availability of appointments. Specifically, this they're focused on COVID-19 immunization appointments, but it's slightly more broad than that. And this, on the other hand, is just it's basically a single test that serves as kind of one of the actors, and all it does is download and validates the data. So you can test very basic, simple sort of IGs, or you can do much more complicated ones. As far as our general test design approach, we opted to write everything in. We basically created a domain-specific language written in Ruby that looks a lot like Minitest, if you're familiar with Ruby and testing. But that means you are writing executable testing code, which means you can kind of test like anything that you can write in a programming language. And we provide all those pieces, and it has all kind of sort of helper methods for things that you would expect, like passing and failing, and with different flavors of that too, like omits, skips and whatnot. There's also a lot of space in there for providing metadata for information to the people testing. Because you saw in the interface, we had a whole bunch of narrative text explaining what we're doing. And so in our DSL, we have a lot of space for that. We also have a way to sort of kind of organize the tests and orchestrate them. So you can have one test take certain inputs and pass them, and basically have outputs, pass them as inputs to other tests. So it allows you to kind of string together a number of tests. And then we also just sort of broadly have patterns for generating tests based on things like capability statements and testing your own tests. So an unfortunate aspect of writing executable testing code is it's a good idea to have tests for your own code, so you can test your own, there's sort of a space where you can kind of in a pattern for testing your own tests. I think I'll just kind of really quickly walk through how our current version is set up, just to give you guys a sense of what's involved in writing a test. I just want to point out that we are actively in the process of refactoring this a bit. So this is what's there now. Over the coming month or two, we're going to refine this a bit, but so some of the sort of terms might switch around a little bit, but sort of this is basically kind of the way it's going to be, where you start out with a test module, as we call basically a test suite right now, and so that's at for example, a Smart App Launch Implementation Guide. You write a module for that. You can organize tests into what we call test sets, so you can have like an option for developers where all the inputs are unlocked. Or maybe you have like a certification test set where things are done slightly differently. Within that, we have groups. So you would have seen in the interface, we group tests in a number of ways. And the sequences is where, that's where the real testing happens. We call them sequences because a lot of our tests are kind of one after another. But that's, where, we have standalone launch sequence where we test a single standalone launch. And diving into the sequence, that's where you're writing most of your tests. So this is our smart discovery sequence where we define a number of inputs and outputs, provide a description, a whole bunch of details. And then within it have a bunch of tests with the ability to add more metadata. And then you actually have the sort of content of the test. So this one checks to make sure that, that a response from a well-known endpoint has all the required fields. And so that's, so this is just kind of pretty basic Ruby code, but it is code. So you can have it really do anything that you want there. And then usually kind of the pattern is you make a request and then you run an assertion against it. And so in this case, we're checking to make sure that there aren't any missing fields, and then we print an output. So that's sort of kind of broadly how how testing in Inferno works. It involves writing code, which has upsides and downsides. The upside is flexibility. The downside is you're kind of writing code. So you are writing code. So that's can be more work. And also has sort of the ability, sort of some of the problematic aspects of that, where you need to write tests for your own tests, basically. One thing I just wanted to sort of bring up is we also have the ability to sort of you can write what we call generators to generate those tests, and so you can look at you can basically write them to look at a capability statement and parse it. I'll just really quickly kind of walk through that. So in the case of US Core, they provide a capability statement that describes all of the requirements. And essentially we have just a script that goes through and pulls out the profiles that are required for each resource. They have essentially when different interactions are required, so shall, should, and we pull all that information out, including searches and shoulds. It's kind of flipping through all this, and then what comes out of all of that is a set of tests that do everything that the capability statement says. So essentially, the process is as you're writing tests, you can write a generator that then will generate static tests that then you basically commit, and then you can run that. So the upside of this approach is to have that sort of intermediate to generating tests is then you can look at the content of each test. It's quite a bit easier to understand what's going on, because especially for something like US Core, where you're dealing with just tons of searches, tons of different resources, and a lot of special cases, it's really nice to have the sort of in-between kind of format of more human readable tests that are actually kind of printed out that you can see. So sort of broadly how that works. And I just briefly, so that's, a very quick, 10 or 15 minute sort of talk on what on sort of how Inferno works and how you might want to use it. I just wanted to bring up some challenges that we've seen that make this, that make FHIR testing hard, especially when it comes to the RESTful API and when you're looking at it from a sort of conformance perspective, especially with the ONC tests. So as y'all probably know, the FHIR RESTful API, a lot of FHIR is optional, and so you don't have to. So you can be fully FHIR conformant and not really do all that much, and that's done on purpose, right? Because They don't want to make everybody support everything, even if you're only going to use a small slice of it. But what makes it a little challenging from a test perspective is that it's hard to have many expectations around what parts of the API they've implemented. It'd be really, for the US core, it would have been a lot easier if they, provided a write capability. So we write and then check, do a read to check to make sure that, and searches that it actually registered and worked, but there is no write requirement, and most servers don't, and for the certification program, don't support write, so we can't test that way, and this sort of just kind of broadly makes it tough to write a sort of one set of tests to that can test sort of any kind of FHIR system. Now there's a capability statement, so there's metadata interaction, but it doesn't provide a ton of detail. There's a whole bunch of stuff that and sort of options that can't be represented in the current capability statement. I know capability statement 2 might make improvements on that, but you can't necessarily infer everything based on the capability statement. And also, I'm hopeful that over time, more implementations out there might start using kind of multi-purpose FHIR servers and services, so that since you kind of develop the FHIR component separately from the other kind of pieces. So it's more of a norm to have a full-featured FHIR API versus just sort of the handful of gets and searches that an implementation guide might actually require. Another part that's very challenging is there's definitely limits on what can be tested. FHIR is, it requires you, in order to be standard conformant, like you have to actually represent the data in the right way, in the standardized way. And so something can look like, perfectly valid FHIR sort of over the wire, but you won't actually know for sure if they did things right unless you inspect the system and make sure that they really mean what they're saying, right? So so that's kind of a sort of a broad challenge, and I think it's a really important aspect. And I think realistically, there's going to be a fair amount of human in the loop sort of testing if you want to get very, very thorough to make sure that systems actually have all the data that are doing everything kind of the right way. I mentioned earlier, I think a lot of times in realistic scenarios, you're going to have a number of standards overlapping. So the Smart App Launch applied to US core, we've run into a million kind of gray areas where, because a lot of times these standards aren't necessarily clear about how to interpret, basically, yeah, kind of, how they sort of overlap. And actually, a lot of the time that we've spent on our team working with vendors in the ONC certification criteria is figuring out the right answer to those gray areas. And then finally, we took the approach here right now of having a test system where you write code. There are a lot of upsides to that. There are a ton of downsides, and I don't know if I haven't quite personally settled on sort of the right approach. We ended up going with our way just because we knew it was most flexible. But I know there are folks out there doing other things, and specifically like the test script resource, and there are certainly upsides to sort of that approach. So this is just kind of one way of doing the testing, but there are other ways as well. And with that, I think I just wanted to just pull up a couple of pieces of information. So all of this is available online. So if you go to inferno.healthit.gov, you can go there for general materials. We have a live demonstration server. This is all on GitHub under the ONC-Health IT organization. So you can check out our GitHub repository. We also have a Google group that you can join. We basically use it just for announcements. Feel free to reach out to us by email. And honestly, where we're the most active is on the Zulip chat. So it's probably the easiest way to get in touch with any of us. And the nice thing about that is if you have any questions, then those questions can benefit the community in general, because it's all public. So not sure how I'm doing on time, but I think I'll wrap it up there. Happy to take any questions now or later in the talk. Thanks again so much for the opportunity to talk about our work. Appreciate it.
Thank you so much, Rob, for presentation. So we have a few questions. Let me start with mine while I'm reading the others. So since your solution is open source, you mentioned that you're looking for other organization to write tests for Inferno. Do you have a lot of organizations which are contributing to Inferno right now in terms of testing tool itself and tests? And what kind of other contributions you're looking for?
Yeah, so the vast majority of the work has been done by our team, but our goal really is to have something where basically accept other contributions, whether it's sort of on the test side or documentation or really kind of anything, even just reporting issues that you find through our GitHub site is hugely helpful. So yeah, I mean, we kind of welcome any collaboration. Love to hear if anyone is kind of willing to do that, and we also accept, of course, we accept pull requests, right? But we'd love to have sort of I guess a deeper collaboration if anyone else wants to kind of team up on this.
Got it. So we have 2 questions right now from the audience, and please send more questions if you have. So first question is from Gorodata. He is one of our actually co-hosts of FHIR Meetups, and also he's co-chair of HL7 Mobile Health. So he's asking about Inferno for other countries, like instead of US CDI, what about other countries' CDI? Can you talk about international work?
Yeah, sure. So the Inferno is it's a generic kind of test system, right? So it's just a matter of providing tests for whatever you're interested in testing. We are, I mean, we have a limited set of tests today, and we're sort of working on expanding that. Excuse me. One implementation guide that we've been providing tests for is the International Patient Summary, which is a little different than like a different nation's core. But if there are other sort of similar U.S. core kind of implementation guides for other nations, I'd be happy to sort of take a look. And depending on how similar they are to U.S. core, it might be fairly easy to do, or it might be quite a bit of work, depending on sort of how it's structured. So yeah, so that's yeah.
Thanks, Rob. So right now there is no like Canada core or like I don't know other countries core already implemented. So it's like possible, but not available yet, or.
Yeah, no, we've only written tests for a right. We only have we don't have too many tests, right? So and we haven't specifically looked at any other sort of implementation guides like that.
Got it. The next question is from Prasanna Siv. I hope I read it right. The question is this tool relevant to DevOps teams who are enabling GitOps methodologies for the application teams, i.e. is this integrated with Jenkins and Git?
Yeah, so you can, and if you go to in the repository, I think in the README, we have an example of being able to integrate it into, so for us, we use GitHub, and I believe we have well, actually, so we used to have a Travis example. I think maybe we have a GitHub example, if that was the question. The one thing is the way it's currently set up is you essentially run Inferno as a command line tool, and so the continuous integration server would execute it. we are looking towards having an API kind of based sort of test system. So instead you can call out to an API, but that's in sort of a future version.
And it's all documented at these links, which are on the screen, right? Like how to use
yes, it is. I'd be happy to hear feedback if it's a little if it's confusing now. I'm sure there's always opportunity to improve.
And the last question from the audience is from Arvind. He's asking if they know Ruby, can they write tests for like other? I believe the answer should be yes, but anyway, for other implementation guides like DaVinci, Drag Formulary, or Karen Blue Button, like implementation guides.
If you know Ruby.
Yeah, can they write tests for other implementation guides like DaVinci or Karen Alliance?
Yeah. And so the idea is that we hope people could write tests for other implementation guides they like, or we can help them. But yeah, and we're it's a pretty generic kind of test system, so you can kind of do whatever Ruby can do. So which is kind of most things. So yeah, so I don't see any reason why you couldn't write tests for those.
The next question was about comparison between different testing tools. So let's leave it for our roundtable. Like, let's see other testing solutions. And the last question I can see right now is writing tests, and this is from Pierre Curie. Writing tests sounds like an excellent opportunity for a software engineer who is looking to learn FHIR. How much experience with FHIR in general do you need to collaborate on the tests?
No, that's a great question, and I 100% agree. It is a great way to learn the spec. If you're testing it, you'll to be honest, we on our team, quite a few of our team members, when they first joined a couple of years ago, this is their first sort of exposure to FHIR, so they learned about FHIR as they were writing tests. So I mean, you can kind of start from nothing as long as you have some familiarity with RESTful APIs and broadly how that works. Yeah, there's nothing I think kind of stopping you from giving it a shot. There is a learning curve, but I think with FHIR anywhere, no matter what part you're working on, there will be a learning curve.
All right. Well, yeah. So we have one more question. I thought to stop after this one. So let's stop after the last one. So does Inferno will cover consent management test cases?
So we I don't think we have any plans to specifically work on that in the short term. But yeah, I mean that's something that certainly could happen. It's just I'm not aware of any plans of doing that in the short term.
All right, thanks, Rob. Please stay with us for the roundtable discussion with other speakers. And let me introduce Richard. Let me share my screen. Yes, so the next speaker is Richard Adama. He is the lead architect for a commercial solution for FHIR testing called Touchstone and company Aegis. I want to pass the word to Richard. Richard, please welcome.
All right, thank you. Let me share my screen. All right, so hopefully you can see that.
Yes, we can.
Okay. Well, I just want to thank Rob and for his presentation. A lot of great information there. So I don't have to repeat a lot of things. This talk is about, from the FHIR specification itself, we have incorporated into it a testing framework as part of the specification, as well as this idea of a test script resource type. And so that's the basis for our approach to testing. And that's how we came about with Touchstone as our testing platform. So hang on a second. Here we go, focus. So we're going to do a quick review looking at the FHIR specification of what that testing framework is, as well as the test script resource. And then I want to spend the remainder of the time really just going through Touchstone through some demos of what the interface looks like and how we actually implement testing using that framework and test script as that executable test definition. So the FHIR testing framework, this was back in 2015, the summer of 2015, so it's a while ago. And there were some folk from the FHIR core team, from MITRE, for a bunch of people attending the May working group meeting in Paris, where we started talking about this concept of building into the specification this idea of a testing framework. And this received pretty good press at the time and a lot of interest. And so we kind of ran with that. And DSQ2 was the first FHIR spec that then incorporated this testing framework and the test script resource as that test definition, that computable, executable definition of a test case, if you will. So this provides us with a testing methodology within the specification itself that we can then use to build a test engine that will validate interoperability across both FHIR servers and clients. And just to show you in the specification, the current official spec R4, there is testing.html if you go there. And I've actually got that on my browser here, and basically just kind of scrolling through the content here. It talks about the execution workflow of the test engine, fixtures, profiles, variables, that information that you're going to need to define your test, operation execution, assertions, and so forth. And so I'm not going to go into all of that detail here, but suffice it to say, you know where to go now to look that up. The test script resource as part of that framework, so it's a first-class resource type in the FHIR spec. Again, been around since DSQ2. It's kind of morphed a little bit from version to version, but essentially the functionality has pretty well been consistent in its definition. So the idea with the test script is that it is like a document, if you will, that defines, I want to run this operation and I want to execute these particular assertions to test the conformance of that operation to whatever you want to conform to, right? In this case, the FHIR specification. An example of this would be the patient search. So if we wanted to test patient search, we need to think about how are we going to build our test script and our suite of tests, could just be one test, but also the pieces that go around it as well too. So if you think about what's involved in that, you need test data. So you might think of one or more patient resources that are required, some that match the criteria, some that don't, of course. A setup procedure that is going to be executed prior to the test that might do those create operations on the target system. And then the actions for executing those operations and the asserts to evaluate the results. And optionally, if you want to clean up after yourself, which is always good hygiene from a testing perspective, in the setup or the teardown, you can actually clean up that test data if you wish. Here's the test script resource page in the FHIR specification itself. And again, I've got that in my browser, so I can flip over here to test script. And just like any other resource, it's got scope, usage, relationships to anything else that might be of interest, and then of course the full structure of the contents of what you're going to find there. It is a bit daunting at first when you look at it. There's a lot of information there that you're going to be defining within the test, but if you think about what a test involves, there's a lot of information, fixtures, variables, and so forth. There's a setup section, and then a series of tests and a teardown. If you're familiar with JUnit, the test script is kind of modeled after that in some fashion, as well as the workflow of the test engine. And we can see that here. So taken from that testing page from an execution perspective, there's 5 main portions to what that workflow that a test engine is supposed to be able to do. Prior to doing any processing, you need to introspect the test scripts, and basically you can do a match with the capabilities of the system under test to determine if that test script is appropriate to execute. You may still want to execute it because you're looking for gaps, perhaps, in functionality that you're testing. The setup comes along as this is performed once at the beginning. So this is the before, if you think about it from a JUnit test. How do I set up and prepare my system under test for those subsequent tests that are going to follow? Test execution, I've kind of highlighted a little bit here because we'll go into that in a little bit more detail. But the idea here is one or more tests that are grouped together. So sequentially, they'll be executed one right after the other. But a test can have a series of actions in it that we'll look at in a moment. But those are going to be the operations and assertions that are going to be performed during that test. Once all the tests have run to completion, there's a teardown, again, optional, that you could put in. And the idea for the teardown is the after event that allows you to revert the system under test back to its pre-test state, perhaps. So that cleanup operation. And then finally, we need to do some post-processing of the execution, so collect all the results and then provide them in a meaningful way to the user on the user interface. So that's what the post-processing is for. The test execution, and again, I'm going through things a little bit quickly here just because of time, but the focus here is on a number of actions that are going to be performed in concert within one test grouping, if you will. So everything within a test all relates to each other. So I have one or more operations. So basically I could perform a create followed by a search to see if I get the right results back, all within the context of a single test. After each operation, I can have a number of asserts, and those asserts are going to be whatever is going to be tested for that operation that just got executed. So on the create operation, I could do something as simple as look for a response code of 201 for a successful create response. But I probably want to go a bit further than that, because from the FHIR specifications perspective, I'm also looking for HTTP headers. I'm looking for the fact that the payloads might be conformant, so I can invoke the validation engine, and so forth. So those asserts are many and varied and have a lot of functionality tied into them. Some key aspects here is that all FHIR operations are supported, the dollar operations, that extended operations framework, and so forth. And the great thing about the fact that we're using the FHIR specification to define those tests is we can actually build an implementation guide around test script if we find that we need more things or more functionality or more definitions of things as well. So if the functionality of the current test script is a little lacking in some areas, we may actually enhance that through extensions and so forth, following the same FHIR specification that we should be. The asserts are going to be the conditions, rules, or expressions that evaluate that immediately preceding operation. So again, looking back at the test script resource, there's a lot of elements that go into both operation and assert, because there's a lot of things that we might want to test. We can invoke FHIR path expressions. We could use JSON or XPath, to go introspect payloads and even the headers and so forth. A very key concept here is that if you execute an operation, it's executed. You're not testing anything until you actually get to an assert. So the operation itself, the FHIR engine will always execute. The testing of that operation is performed by the asserts that follow it. So, something to keep in mind. So just kind of a whirlwind overview tour, if you will, of what that FHIR testing framework represents and what that test script resource is as an executable test definition. Support for the entire FHIR RESTful API, support for all operations, and for the asserts that evaluate them. So that's just kind of a quick whirlwind tour. What I'd like to do is leverage our Touchstone platform to actually go through and demonstrate how these things actually work together. Now, Touchstone is available as a publicly accessible cloud-based testing platform. The URL to get you there, that's the shortcut, if you will, touchstone.com. It'll redirect you to our main site. So our primary site is hosted in our data center here in the DC area. And we provide a platform. And so it's not just a single, application that's deployed out there. We have a lot of services behind the scenes that are supporting everything that you see within the Touchstone UI. Validation services, terminology services, and so forth that go into all of this. But the idea here is that we're providing an automated internet-based way of doing that interoperability testing of the FHIR specification, including other things like CDS hooks and so forth. So as we continue on with our development of Touchstone, other specifications that are FHIR related, and some, if we decide are not FHIR related, we could probably go into as well too. But the main purpose here, of course, is to test the capabilities of and the interoperability between both FHIR server and client implementations. So with that, I'm going to drop into my browser and go into Touchstone. So hopefully I can pump up the volume. Whoops, sorry, one more time. There we go. There we go, make it a little bit bigger so you can see. So when you go to touchstone.com, our main landing page, which you can also get to in the main logo here, is basically just where you're going to find information about the tool. We have some nice links here to our online documentation, perhaps some feeds over here for blog posts and so forth. And we also announce what we've been doing with the product. So back in 2015, after that framework was introduced into the FHIR spec, is when we first started developing Touchstone. And at Connectathon 10 in October of 2015 is when we first introduced Touchstone to the world, if you will. And so Touchstone became live at that time, version 1.0. Basically at the time, it was a free service that we made available, and that lasted for a couple of years as we were refining the tooling and so forth. But eventually, what we've done with the tool is we've now provided this as a subscription-based service. So if I look at the subscription page here, you can see that we've got an open free lane, so there's no charge if you want to come in and create an account. But then we do have some paid lanes, if you will, that provide additional services and capabilities. So it's important to understand what you're getting based on your subscription level. But a lot of people come in for the open free lane, and then they're able to just jump in and start running the publicly available tests that we've got out there. From this non-logged in or not signed in yet, I can come over here to our navigation area on the left and just click on test definitions. Well, test definitions are our suite of test scripts that we have published or uploaded into the tool. There are a number of predefined folders here based on the various FHIR specification versions. And you'll note that there's a lot of duplication here as we go across FHIR specs, but primarily we have three main categories. We have advanced, basic, and our Connectathon suite of tests, if you will. So the basic suite of tests are those that for the individual resource types. So for A through C, and this is just for purposes of navigation to make it a little bit easier. So if I were to come over here under P-R, I'd see patient, person, practitioner, and so forth. You click on patient, and you'll see the 4 test scripts that are basically laid out across 2 subfolders here. These test scripts have been around for a while and have we keep moving forward, but the idea here is we're providing some basic testing for essentially the base FHIR API, so those CRUD operations, create, read, update, delete, along with history, vread, and delete. So it's actually a nice little workflow that we've built into these test scripts that do them in a particular sequence. So I don't have to do a setup here. I can just have the first test do a create, and then I can just go right into a read, into an update, into a vread, and so on in a nice little sequence. All the test scripts are accessible, So these are all links here. So all I have to do is click on the link, and we will show you exactly what that test script resource looks like. So here in the context of what we're doing, there's a lot of metadata up front. Notice we do have some extensions here. So we actually have built an implementation guide around test script to provide some additional functionality that we feel is necessary. A lot of extensions here. Let's get past that. Here we go. So we get into the main meat of the test script, and again, metadata up front. So we've got, the date this thing was actually published, who published it, contact information. But then we get into origin and destination. Well, this is how I indicate who are the actors that are going to be involved in the test. So I have a FHIR client and I have a FHIR server. So the FHIR client, by the way, can be represented by Touchstone itself, or you could actually connect up to an external client, and then Touchstone would just simply act as a man in the middle and wait for requests coming in from that external client, and then the response coming back from the server would be captured. Fixtures that are needed for what we're going to be testing is, we need something to be created, we need something to be updated. We need to provide profiles for profile validation. Remember, search history are going to return back bundles, so I may just want to use the default FHIR bundle profile to do that. The validation engine is smart enough to know to go into each bundle entry and apply the correct validation based on the internal resource type. Operation outcomes might be coming back. I need to have a profile for that. I'm testing patient, so I'm going to do the patient profile here. Variables allow us to capture data from within fixtures. Those fixtures would be the resources, whether they're returned from a FHIR server or static fixtures that I'm going to use as part of my data for creation purposes. And so that's going to be the resource create fixture, which is up here, and then there's the reference to it. So I'm going to upload that along with the test script. So the variable will go into that fixture and then pull out a piece of data that I'm going to use for testing purposes, probably in an assert later or in an operation. In this case, I have a setup where I am going to be doing some cleanup ahead of time. The idea here is, rather than wait for the teardown, I want to make sure that what I'm about to create doesn't already exist. Because if I execute this test script again, I'm going to create another instance of that resource. So I want to make sure that, I'm not going to create yet another instance of that same resource for testing purposes. Depending on the response I get back, I'll continue on until I reach to the end of the setup. If the setup process were to fail, if any of those operations were to fail, the test engine would know not to continue. And so it would not even attempt to go on with the tests that follow, because if the setup fails, then I don't know what the state of my test system is. And so I don't want to necessarily continue on with invalid testing at that point. Assuming setup goes completes successfully, then I start in on my test. So here I have a create operation actually using the update form of create. So I'm going to call an update operation, but with the intent to create. And so that's all part of the FHIR specification and so forth. But I'm expecting a created response back. So we have coded values, or we can use response codes 201 and so forth if we want to. So, that's just kind of what the structure looks like, and it's going to continue on from there. So what I'd like to do is I'd like to execute this thing. Now remember, I'm not signed in, but if I click on this and select it and do a create test setup, it's going to prompt me. I need to log in. So I'm not just it's not just simply open in that regard to let you run anything that you want. You have to log in with an account. And remember, the account, you can be in the open free lane. I have a demo account that I like to use, so I'm going to sign in as my demo user. And remember, I started with a test setup, so it's going to continue back to to that page that I started to go to. Test setup means, well, I can save this definition of these tests or tests that I want to run with a particular name. We'll give you a nice generated name based on what test scripts you've chosen, but I can call this whatever I like. Right? So this could be, Richard test 1, okay, or test exclamation. There we go. But whatever you choose to put here, that's going to be saved for you so that you can come back to it again at a later time to execute. The origin is going to be predefined here initially with the Touchstone FHIR client. So this is Touchstone acting as the client. What it means then is wherever an operation is going to be executed, Touchstone will perform that execution based on the definition of that operation in the test script. It's important to understand that because I can define operations that do bad things, and that's great for negative testing. So it's important that when you're building your test script and defining those operations, that your intent is either as a happy path, let's do the correct operation, or I might want to throw something bad into the mix to try to force errors to occur. And when I'm testing for correct error response. So it's interesting, if I get an error back, I might get a successful pass on the test. There is validation involved in test scripts. So there's an assert that will invoke the validation engine. So we've incorporated that same validation engine that Rob was talking about that Inferno uses. So we have the HL7 FHIR core library that we've incorporated behind the scenes as a service to Touchstone for each FHIR spec version that we support. So from DSTU2 to STU3 to R4, we have a version of that validator for each one available. And that's shown here. So we actually have multiple instances of validators because I might have a validator that uploads US Core 311 as an implementation guide, but I might have another one where I want to use a different version of US Core, perhaps, or I might have DaVinci profiles loaded or so on. Depending upon the test script and the test script author, they're going to choose which validators are appropriate for that test script execution. In this particular case, I just have the base validator. And so that's going to use just the base FHIR specification profiles as well as a suite of implementation guides that we've uploaded and are maintaining. So I'm going to go ahead and execute this since there's no other data that I need to put in here. And you'll notice I'm actually chosen my Aegis Wildfire server here. So I have a Aegis Wildfire is our reference implementation that we put together that was authored back in 2013. That's when I went to my first Connect-a-thon. I was told to build a FHIR server and client. And so this is what's come out of that. But I'm going to go ahead and execute this after choosing that as my destination. And so now here we get to the test execution page. And there will be an auto refresh happening here, so I don't have to do much. I can just sit and wait and watch things progress forward. And you can see as it's going through the tests and when it finishes. And green is good, so everything passed. I'm interested in the details of that test script execution. Remember, I'm up here at the test execution level where I might have multiple test scripts. Each test script execution itself is a link to drill down further into those details. And so we've got some helpful summaries, if you will, up on the top here, some metadata and so forth. Who did this? When was it done? The exec ID up here is actually a permalink, if you will. So the URL up at the top here is a permalink that you can always go back to and check your test results. So 2 years from now, you could use the same link and find those same results. But we have a summary here of all of the interactions across all the resource types used within the test script. And then over here are the individual tests that were executed as well as the setup. So the setup, I can show that, and here are my individual delete operations, and there's an actual create operation for organization. Remember, there are references between resources in FHIR, so the patient has a reference to a managing organization. So I want to make sure that that gets created up front, because I'm not worried about testing the organization, I'm testing the patient in this case. But I want to make sure that that reference is going to be valid when I go to create my patient. The create operation, again, a lot of click and expands going on here as you drill down. We didn't have any failures here, so if we did have failures, we would automatically expand to the first failure point for your examination. But since everything passed, we can then keep clicking. These little ellipsis dots here are also expansion areas. And you can see here's all the details. So this is the URL that was submitted. Here it was forwarded. So basically, remember that Touchstone can support external client to external server by basically providing a proxy in front of the FHIR servers that you're testing with. So the external client, if you were to use one, would need to know to go to the proxy provided by Touchstone, and then we can intercept the inbound request, forward it on to the actual FHIR server. We're not going to manipulate it or do anything with it. We're just going to capture it and then send it on. All of the information about the request. And since Touchstone sent the request, let's look at the definition here. So this is taken directly from the test script. And so basically it's an update that we expect to do a create on the patient resource where we're going to accept JSON content and we're going to send JSON content. So these are going to be the generated HTTP headers for the request. And you can actually see that here. That's exactly what we generated here. So these are coded values that expand out to the appropriate MIME type and care set, for the accepting content type headers. If we wanted to add any additional headers, well, there's additional fields for you to put in any headers that you want to send in that request as well, and Touchstone will generate those as well. It's going to send it on to the origin that was defined, and that's going to be my wildfire server, and I'm going to capture all of the payload and response information. So here from my wildfire server, it sent me back all of this wonderful information along with this payload, and I'm going to echo back the patient that was created with the generated resource ID. Okay, so again, all of this information readily accessible, a lot of click and expands that are going on here, but once you start to get used to the interface, it's actually pretty nice to kind of go through. Some examples of things that we can do from an assert here. Again, very simple, check the HTTP response code 201. Again, I can use it as a coded value. I can actually invoke what we call complex rule sets, and these are the extensions that I mentioned before. As Rob mentioned, one of the aspects about having a coded language is that you have a coded language. You can do lots of fun things with a coded language. But with the test script resource, by default, it's just this document of a resource. It doesn't have coded language within it. So we've actually extended the test script resource to provide what we call a rules engine, where you can actually use Groovy script that will take the context of the operation and provide that to the Groovy script in a secured manner. There's a lot of security going on here because we don't want to expose things. But then all of that context is available for you to introspect through the Groovy script language. And so wherever you see complex rule set, this is where you get some interesting things going on. But we're checking HTTP headers and so forth. And then we're actually going to come over here and make sure that the resource body is of a correct resource type that we would expect. Because as Rob mentioned, the FHIR specification has a lot of optionality to it. One of the things that the create operation can do when it returns is send back the echoed back thing that we wanted to create, or it could send back an operation outcome, or it could send back nothing, and that's okay. That's part of the FHIR specification. But how do you define that in this type of rule and so forth in the test script? So with a rule, we can actually provide what we do in terms of skipping things. So if I have an assert that doesn't need to be executed because, I sent back patient in the response and not operation outcome, I'm going to skip the operation outcome assert and do the patient assert, if you will. So that's just some examples of things that we support here. The read operation is going to follow next. And here's the actual call to the validation engine. So validate profile ID with a resource identifier here. So resource-profile was defined up in the metadata of the test script to be that canonical URL that you wanted to validate against, whether that's going to be the bundle or a patient or whatever it might be. So you can keep walking through this and just see what all these different steps are. Fixtures, so this is the data that was involved. And so here, the raw data, so here, interestingly enough, you can see this is the raw format of the data. One of the things that is defined in the testing framework is the use of variables. Well, we've taken that and expanded on it, again, through our implementation guide with test script, and come up with these placeholder variables, if you will, that provide some functionality. So let's say I wanted to generate a UUID with no dashes as the ID for my patient. If I wanted to come down here and just use some placeholders that would generate some random strings for me, I could do that. Or I have a current date function here that would subtract 10 from the year value to generate an appropriate date, for that test, and so on. So there's a lot of interesting things that you can do here in the static fixture. And as part of the pre-processing that Touchstone does, it'll examine all of that and then do a search and replace functionally with those placeholders, so that we get a resolved data of, here's my generated UUID. Here is the timestamp, right? So that date, that's a year in the past. So 2011, May 4th would be my period start, and so forth. So we provide access to all of that here so that you understand this is what was defined, but this is what was actually used in the process of the test. Here you have the profiles that were defined. So again, the actual canonical URL allows us to pull out of the validation package, in this case, the base FHIR specification, and we can actually find, here is the actual structure definition context that define that profile. So if you're using an implementation guide's profiles here, we're going to pull that out and make that accessible to you as well too. Variables for pulling out pieces of data that we're going to be used for testing. And if we do have rules or rule sets, we're going to list them down here along with all of their parameters that would be utilized as well too. So I could actually drill in and, all the way down, and here is the Groovy script that was coded to do whatever this particular part of the rule was meant to do. Okay. So everything's all clickable and accessible within the tooling here. So that's just a quick example of a test script execution that I can run. The test system itself, here by WildFire server, if I just click on this, it'll take me to the test system definition page, where here is the name that I'm assigning to it. So I like to put in the FHIR version, but our FHIR specification version, we've been supporting the Connectathon since DSTU2, so all those snapshot releases are here as well too. What formats do you support? What's my base URL? We'll go out and find your IP address for you when you define your test system. And then we've got some security features here as well too. So if I define a test system for me as an Aegis person, I might want to make that publicly accessible for everyone within Touchstone. So I can just say viewed by, execute by everyone. But for purposes of testing, and I don't want to make this like a reference implementation that anybody can use, I may want to hide this within my organization. So if you do that, and I go back to say the test setup, this drop down here is going to show me all of the test systems that I have for my organization that I have access to, but also any publicly accessible test system. And you can scroll down and you can see we've been supporting the DaVinci implementation guide testing for now the last 2-3 years. So we've got some DaVinci reference implementations that have been built by various organizations. FHIR with their ONC server, I think they call it now. I'm not sure what the new name is now, and so on and so forth. There's Graham Greaves server, Health Intersections, all of these things. Oh, there's MITRE's synthetic mass server from a while back. But all of these things are, if they're publicly accessible, you can see them in this dropdown. You can choose them as destinations for your testing. The reason you might want to do that is because, well, you may not have a FHIR server. You may have a FHIR client, and so you need someone to test against. Touchstone is not a FHIR server. Touchstone is a testing platform. So you need to have a publicly accessible FHIR server to talk to. Oh boy, history. So all test executions are saved. Oh, sorry.
Richard,
Paul,
we
did you have something?
like close to end of time, and
Okay.
let's maybe answer a few questions if you don't mind, a couple of questions. And,
Sure. Yeah,
switch to-
definitely.
Thank you for the presentation.
Mhm.
So questions, like talking about your test, like we saw a lot of tests you have shown, right? So the question from Gora, probably you can answer better than Inferno. You probably have a lot of international tests. Is it correct?
So the test definitions we have in Touchstone are based on who we are working with. So we've actually been working with some folk in the European space. Nictus from the Netherlands is a big user. So their MedMe profiles and so forth for their certification in the Netherlands. I believe Medcom.
What about Australia core, Canada core, like other core besides US core?
Well, actually, that would be in the validation engine. So if you have access to a validation engine, so if you have, each user has roles in Touchstone that allow them access to certain features. So if you are granted access to a validation or a validator, as we call it, you can access these different validators based on specification. So here's that 401 spec I said. So here's all the IGs that we have loaded for our base FHIR 401 validator. You'll notice most of them are DaVinci, but there's, this one, the base FHIR validator in Touchstone is what everybody has access to. But,
right,
and so I don't have any other 401s there. Let's see. Oh, the problem here is that I'm connected as my demo user, so I can't show you everything. So if I were to go to 302, right, I can only show you the base validators. So I'd have to log in as an administrator to provide access. But you'll notice here for 302, we do have the Australian base 1.1 implementation guide. Back in the time when we were doing a lot of STU3 work, I was talking with the folk in Australia and they wanted their IGs loaded up. So in our base 302 validator, we have Australian base and the Australian provider directory IGs. So as we work with organizations, corporations, and so forth, IG writers, we're happy to work with people and say, hey, if you want to upload and make your IG available in our base validator, we can work with you.
Got it. Thank you. And the last question, due to the lack of time, is Yuri is asking: is there any open source runner for test scripts, and are there runners which can be used in a CI continuous integration environment?
So we don't have a command line interface for a Touchstone. As I mentioned, Touchstone is a platform, so there's a lot of pieces behind the scenes that are supporting this. Like the validators all run on different servers as services to Touchstone. So providing a downloadable version of Touchstone is not something that we have right now. We are looking at, as a future enhancement, the ability to package Touchstone as something that could be put behind a corporation's firewall for their own purposes, but that's a little bit further down on our roadmap right now. In terms of using it though with, say, a Jenkins or Travis and so forth, if you go to our online docs, we actually have a continuous integration section in the online docs where we actually go through the Touchstone API. So everything that I showed you for the test execution, you can do through this RESTful API that you can talk Touchstone with. And so this provides a mechanism for integration with other tooling. So the idea here is you create a test setup, and that could be 1 to 100 test scripts, however many you want to put in a single test setup. And you can then authenticate through the first API to get your access token. And then you use your same user credentials as you would normally log in on the UI. And then you can launch that execution, launch that test setup by its name. Remember I showed you that name that I gave it? So remember what that name is, because you're going to use it to execute it remotely. And then you can query it through these status APIs, if you will, to find out the status of it. But there's a whole example here of how I integrated that into our internal Jenkins build server for my Wildfire server. So when I build Wildfire, one of the last steps in the job is to invoke the Touchstone API. And then it'll take that wildfire server that I just built and deploy it into a container on my build server. So now it's up and running, and then I can launch various test setups, if you will, to execute my final suite of tests against my FHIR server. And this whole section here defines all of the pseudocode. This is actually the code that I wrote at the time, where I've taken out my credentials, of course, for logging in. But it shows you how to do all of that through the Groovy plugin for Jenkins.
All right. All right. Thank you, Richard. Again, we a little bit over time. So thank you so much for your presentation. Please stay for the discussion after all the presentations are done. And let me introduce the last speaker for today. Okay. And so the last speakers, actually not speaker, are CTO of Health Samurai, Nikolai, and Yana with Health Samurai. Health Samurai is more famous of the 8-blocks FHIR platform and server, but today Health Samurai will share what they do about FHIR testing. So guys, I'm passing the word to you. Please pick it up.
Okay, thank you, Pavel. Let me share my screen. Okay. Can you see? Oh, not this one. Okay, can everyone see it?
Yes, please.
Well, great. So I'm really happy to see everyone here. And let's start the conversation. Today, I will talk about a StressT tool and do a quick high-level overview of its capabilities and practical aspects of its usage. So the agenda for today, just tell you more about what is StressT, why we decided to develop it, and which features we are proud of, and basically how to write tests with this tool. Let me provide you a little bit context here. The StressT is a lightweight and flexible tool for testing FHIR API, and it's simple and declarative. Basically, this is Data Dsl, which can be used for testing FHIR API and any kind of REST API as well. This is a just freshly developed open source tool, and this is the first time when we are speaking about it, when we are presenting it to everyone. We developed it because we had a demand for our own clients, for our own team. 8-blocks, which we are developing, is not only a FHIR server. This is a FHIR backend for development of FHIR first applications. And at this point, this is a very flexible and customizable solution. And we need to make sure when we deliver it to our clients, we need to make sure that we configured everything properly, that, and we can define various kind of restrictions, various kind of configurations, and so on. And so the question was how we can test that everything is set up properly. So one approach that we have in our engineering team, that everything should be automated. We aim for automated testing approach, and we use it a lot during 8box product development. We have lots of examples of automated tests inside of 8box. And we started thinking how we can utilize it when talking about conformance testing for our clients, when we talking about verifying the profiles, definitions, when we're talking about different like ONC rule and other stuff. And also, if we are talking about the question more broadly, what if we need to test not only the conformance? What if we need to test some business requirements as well? So this leads us to the response that we need a tool that allows us to do that. And we took all these features from the 8box core and put it as a separate open source tool, which is StressT. And the good thing about StressT is that it's really, really easy to understand and easy to write tests on it. Because another issue that we have met when observing the current solutions, that you cannot find a good test suite for any already well-known FHIR scenarios. For example, let's see US core, let's see some implementation guides. There are no publicly available and community-driven test suites that you can just pick and plug into your current solution, right? And the question was, can we define the tool in the way that community can easily contribute and can easily maintain the tests by themselves, not with our like main efforts, right? So the idea here is that we are publishing also the set of tests that can be maintained, contributed, and so on by the community. Okay, and another nice thing that it's easily to configure with your CI/CD pipeline and run tests with like GitHub or GitLab or whatever. What else? Some features to highlight here. As I mentioned before, this is open source. This is easy to start using because the project structure that that needs to start working with StressT is really simple, and we provide you with a generator that you can just launch in few seconds. It's powered by declarative Data Dsl, which is clear, minimalistic, and easy to understand. And you already have some examples behind your eyes. You can like see the patterns and reuse them. And we have a unique assertion engine, which called MITRE. It's really very cool because you can do some advanced stuff, like you can pass data and from like various steps in the test. For example, it's data extraction. This is a challenging part when we're usually talking about like FHIR testing. And also it's powered by embedded closure features. So you can basically do some programming when you write in these test suites. So this is really good tool. And it's still under the active development, so we will release new features very, very soon. A few words about the Data Dsl we're using. It's on top of EDN format, which is extensible data notation, which is superset of JSON. I guess everyone here at least heard of JSON, but most of us are using it on the daily basis, and we know very well the structure, we know how to use keywords, and so on. So the syntax is like similar, but the little bit differences here, how to define keywords, how to compare, like how to compose collections and so on. But you can, I guess, easily manage it just by looking at this example. So it was a really quick introduction, and the main focus of this presentation would be the demo part itself. So right now we will write some tests on Stress-T with you. So here is my local environment. I have just installed the Stress-T utility from open source repository of Health Samurai, and installed it by the instruction. Here we have like STU. This is the utility itself. When we run it, we see the help section here, and we can explore the available options together. So what can do Stress-T? It can run tests by test command. It can help you generate new project with gen command. We can configure server here, and we can run the validation by check command, and basically read the help options here. So what we are going to do, we are going to generate new project right now. So let's create new directory for it. Okay, cd meetup folder, and let's generate a project. Okay, so let's see, the project is generated, and right now we will open it with basically any text editor. I prefer Sublime, so I'm using it, but you can use your favorite tool. Let's see here. Well, the project structure is like this. There is a envs file which contains the environment settings. You can specify here, for example, staging, test, and production environment for your testing, or you can add various FHIR servers that you would like to run your tests on, and so on. I have a local instance of 8box right here, so I will specify the local host, and I have enabled basic auth, so I will provide here the username and password, and password. Okay. So and other elements of the project are namespaces. We have a myproj namespace here, which contain a case. It could have multiple cases, and each case contains from steps. So basically, let's say we have a myproj case, and define case here, and this is case. So let's see how the utility will execute this test suite. Okay, so the tests were executed on the local FHIR server. and there were executed 3 steps. All of these steps are successfully passed, and the summary is like this. Let's see how we can see the output in a more detailed way. We have, could you please repeat? Okay, so let's set up a detailed format for output. Okay, in this option, we can see the whole content of the request and the response. So it's really useful when you need to understand what's going wrong, what are the expectation, and what is the actual result. If you are not interested in the details, you can specify the compact format of output when you need just a summary. Okay, and you see just the summary here. Another great option here, and this is when you need to save the report and to see it later on, and for example, pass to your CI/CD runner to show somewhere. I will, I guess. This basically what it created HTML file and put it into the repository here, and we can just see the result of execution of these tests with all the details, with the body, the result, and the match expression. So this is another option. That's it. Later, what we can, what else we can do here? So I suggest that we can go through the tests and try to write the new one, and I will explain you what is the test structure, how we can describe things, which capabilities we have here. Another thing that I wanted to show you, these are validation engine. Let's do a typo here. And then executing validation over this case. STU and check. So you can see that the validation engine mentions that STU HTTPR is like unknown stuff here, and you should go to steps second section and check what's going on. So we can fix this typo and then execute check again, and everything is fine now. Well, let's try to write our own test step. The test step itself consists of the following items. First of all, this is the ID. The ID, you need to define that it gives you the ability to refer to this step later on during this scenario, right? Let's say this is my step, for example. And then you can define the description. The description, this is just a string that may be useful for your report later on. Okay, two main sections here is do and match. In do section, you describe which actions should be executed. In the match, you will compare the result, the actual result and the expected one. So do and act. Let's say that we are going to define act. This is an action that should be executed. It's pluggable stuff. Currently, Stress supports like HTTP, mostly HTTP requests and the print operation, but this is going to be extended later on. Okay, next we define the method. And like get, put, post, patch, delete, everything is supported here. So let's say post, because we would like to create some new patient, for example. And next one is URL. We define the URL that should be executed. Patient, and then we define the body. What we would like to define here. Let's say the resource type. This is patient. And let's say that we would like to define the birth date for it. And the birth date will be, let's say like this. What else? Next, not act, match. Here we will check how the request is executed, what is the result. So the validation will be done by MITRE engine. So MITRE, what we are checking currently. Let's begin with a simple check, and usually we say that everything is fine when the status is like 200, right? Let's save this and see what will be the result of the test execution. Okay. And now we expected 200 and received 201. That's because for creation of the resource, we will get 201. And in other cases, we will get 204 or something like this. And to don't care about the particular code, but make sure that that the test execution goes fine, that everything is correct. MITRE has some predicates. For example, we have an okay predicate. Is everything okay? We can just ask this. And now everything is fine. Well, what else? Usually, in the tests, we need to make sure that the data that we are creating not spoil everything and so on. So we care about that cleaning up data. And one approach is when we clean up everything after the tests are passed. And another approach is clean up data before test execution. For example, you need to work with the particular resources, and before executing tests, you're cleaning them up. And after that, you're able to understand what are the results, to work with this data later if you need. And before other tests, you can clean up everything again. So I suggest us adding the step when we will cleanup patients. Let's say this is ID clean data, and description is optional, so we do and match. So what are we going to do? We are doing act again, stu http what method we are doing. Method will be get and URL. So in most FHIR servers, you're dealing with just you can delete resources one by one or delete them in transaction and so on. But here, since I'm working with a local installation of 8box, so it has access to SQL endpoints, so I will just truncate the whole table. This is an SQL endpoint, and the body will be truncate. That's it, I think. So okay. So and let's make sure that everything happened smoothly. Okay. Let's try. Okay, the data is cleaned up. Let's see the detailed report. So basically, right now we just started to write tests here, and it's quick and easy, as you can see, and also the good thing that we basically created a set of tests for CRUD operations, for FHIR search, and so on, and we called it like stress FHIR, and we uploaded them in a separate repository. So let's see here on these tests. You can see like create case. You can see like delete, patch, update, FHIR search, transactions data, and so on. And for demo purposes, we already configured the CI runner with GitHub actions here. So every commit to this repository running all these tests, and you can see the results here in just an HTML page. You can see like all details. So this is just a nice representation, and so the main message here that I would like to offer you, that please go take a look and try these tests out by yourself on your local environment, on your CI/CD pipeline. Try to like enable your FHIR server here and see what are the results, create any issues, create maybe feature requests or test use requests here, and maybe let's write the good test suits for all well-known scenarios together. Let's maintain them together and having a good community-driven repository. I think this is the main point of having this tool. And also, I wanted to say that I'm also presenting this tool at the FHIR Connectathon in May 17, and just in a few days from this. So if you, for example, take a look at this tool and you have some questions, you can just join the Connectathon, and we can sit with you and write tests that you are interested in. We can discuss like all questions here. Also, we really would be thankful if you take a look at the Stressy tool itself, and maybe you can think how to use it, how to apply it to your own scenarios, your own projects or products, and maybe you have some ideas in mind, and you can share the with us your vision of features that should be included to this tool, and maybe you can just create issues here, like some ideas from your head, and let's do it community driven. And maybe a month later we can set up a workshop when some of you have more questions. We can just work them out together. So I think that's mostly it. And this is time for your questions.
Thank you so much, Yana. Actually, there is no question so far from the audience. So I'll ask a couple of questions myself. Right. So first of all, we saw a couple of tools which already been on the market, right? So what actually pushed you to build another one, and like what was the missing component of the existing thing?
Mm-hmm. Okay, so I guess there were a couple of questions from our audience regarding these tools that already raised during this meetup. The first one is you cannot easily find a publicly available test suites for well-known FHIR scenarios that you can easily to contribute to, you can easily to maintain to, and so on. So I don't know why, but this is the reality. And the intention was to do it so much easy that everyone is really do not need really high technical skills to maintain these tests. The first one. And the second one, the second point is that it might be that in the real life you need to test something that is more widely defined than just a FHIR resource or some logic behind it. So we need to extend the use cases that should be tested a little bit to make it closer to the real life and the real business needs, something like this.
Yeah, so that if I understand right, so the test allows you to test something beyond FHIR specification and extend it further, right?
Yes.
But so talking about basic tests, I mean, have you explored like collaboration with other tools? Maybe we can move towards roundtable, because I think you know, anybody can benefit from tests, right? And if there is a possibility to exchange tests between different tools, maybe that's the answer for many questions.
I think we should definitely start some maybe discussions and collaboration and see how it can be moved forward.
So how can we move, Mike? How can we move it to roundtable?
Hey everyone, Yana, just please stop sharing your screen.
I'm okay. I'm stop sharing. Okay. So.
All right, guys. So let's start. Any questions speakers have to each other? Maybe anybody wants to start? Richard, Rob, any feedback on other guys' presentation?
Maybe I can join. So Mike, can you add me to the screen as well? Sorry, guys, I missed this talk because, can you hear me?
Yeah. Yes, yes.
You can see me, yes. So I'm from COVID land, sorry. That's why I missed this talk, but yeah, I feel better. Yeah, I can tell more about the stress test. Yes. So what we try to do, this is our general vision. So we are working on so-called unified DSLs approach, which is called then-lang. And the stress test, it was one of exercises. So it's it's the first DSL we open sourced based on this platform, this framework. So I hope you like it. At least you may try it probably. So it's more generic than the rest of FHIR tools. So it's not FHIR at all. It's just for testing REST API. But it's maybe applied to FHIR. I think this is a strange direction that we started applying a lot of FHIR specific features to the testing frameworks and then start extracting, making this frameworks more general. So probably it's better to go another way, to do the general tool, which will be useful, and then make it more FHIR specific, or maybe GraphQL specific, or maybe, I don't know, Open API specific. Too much direction to follow.
Not a question, but I have an observation. Looking at the script, Yana, that you were putting together, it did remind me of test script to some degree. And early on in what we were doing with Touchstone and test script, we were actually looking at how could we create a DSL language that could be used to generate test scripts, to simplify them to some degree. So this looks very interesting.
Yeah, they both data DSLs. So we are from the Clojure land. So maybe you heard about the Clojure language. And the approach to express different DSLs and data is very popular in Clojure world. So we express routings and HTTP for HTTP server, even SQL, any rules with data. So the same approach you took with a test script. Yeah, but it's influenced by test script, but it's mostly influenced by Clojure land and by data DSLs. So what's a nice feature from the stress test, I think it's our matching engine. It's like a pattern matching. So it's kind of really easy to write the multiple assertion with in a very simple form. So you're welcome to apply the same to test script. So,
well, as Yana mentioned, we at the upcoming Connectathon, my colleague Ryan and I are going to be doing our track leads for the test script and FHIR testing track. So I know Yana, you'll be there, Rob, some folk from MITRE as well too, and some others that, it'd be interesting to kind of see how we can collaborate a little bit more on these tools, and look at how, it'd be nice to be able to see, okay, I've got, a stressy script. How can I use that in Touchstone? How could I use that in like a Crucible Inferno? Is that something that we could start to leverage, coming up with more of a common ground, if you will? Just trying to think through some things.
Yeah, this is the first time that I've seen this. Obviously, I think it's great. Yeah, I love it's all open source, and we can. Yeah, I'm definitely going to try it out. Yeah, that was the similarity to test script is something that struck. Well, I don't know if it struck me, but it does seem like there's a pretty close, matching, matching there. And from your perspective, so could you use this to test something like OAuth, which is, a little bit more. Let's do some kind of sort of strange things, right? Like stand up an endpoint potentially for redirections. I guess just broadly, what sort of the are there any limitations here that you know of, or is it just sort of a matter of, if you're willing to put in the work to add in the extra extensions, you can do that?
Yeah, so essentially we extracted the test script ideas from our tests which written with code. So we tried to make it more and more declarative.
Yep.
So and we took essential piece as well. We used very nice engine for closure execution, which may be embedded inside. So we are not forcing people to write a lot of code, but for some smart predicates and some transformation, it may be just embedded into the script. Because and we don't have a conflict because closure code is a data, it's a Lisp, so we're still in the data land.
Yep.
And I think there is no limitation because we potentially may cover everything, and it's extensible. So you can add more matching engines, and you can add more action engines.
Yeah, I guess to follow on with that, if you're going to do OAuth in that flow, you'd have to be able to take outputs from one as inputs to the next or subsequent things that you're going to be doing. So is that part of what you're able to do right now, or is that something you'll need? Okay.
Yes, you can, if you take a look on the test suites that we already put in the repository, for example, there's the search one and so on, there are examples of how can you just pass this data through one step to another.
Mm-hmm. Great.
But what's interesting, I missed my part, so I will make the talk for now. So, so the Zen language, which is behind, it's organized like a program. So it has namespaces, it has symbols like your functions or classes. So it's not just files. So I think this is our interesting invention. So you really build a project like you build a Ruby files and requires, or JavaScript and requires. So, and this is, the idea of then I will probably present it in the future. It's a unification of multiple DSLs. So you can mix and compose different DSLs. So if we think that doing some HTTP action can be expressed as DSL, assertion and matching maybe DSLs, validation against schema maybe DSL. So we are already converted to this DSL some of structure definitions. So it's interesting language, but it's not limited to FHIR. So it's a little bit broader. And I hope in future we will make 8-box configurable through this DSL. So it's going to be the Lego for the FHIR server. But probably crazy idea.
I just had a thought. The FHIR shorthand or FISH is another mechanism, to generate FHIR resources. So we've actually been looking at that as a way to yes, I know. But yeah, is there any correlation with Stressy and ABOX with what you're doing with shorthand?
We started at the same time. We discussed with David. So the motivation was that it's too much to write when you want to write the FHIR structure definition. But we took slightly different approaches. So the shorthands go into like markdown side. So they decided to make like a sugar. And we went to the Data Dsl more inspired by Clojure into the open world. But what we started doing, it's a translation between all of these formats and definitions. So we can probably apply the same approach for the test script. So it may be translated to Stressy or backward, for example, from Stressy to test script. So I don't know, we probably can generate Ruby code for Inferno if we really need it. Yeah. But the same engine, so the core of engine was written in a couple of days. So probably, so we can implement the same engine in Ruby for, for StraceT. Now it's in Clojure and it's compiled by Graal VM into native executable to start faster. But essentially it's a specification. So we can implement it in JavaScript and Ruby, and it will take just a couple of pages of Ruby code or JavaScript code. So it's really simple internally. If you go, it's just like 10 files with 100 lines of code. So that's all generators, all this stuff.
Anybody in the audience have questions for any speakers?
Okay.
If no more questions,
I have some topics. So you touched the generative tests, and I dream about this for the FHIR. We did this in code. So we generated all possible combination of search parameters, resources, and even found some bugs with very strange bugs. So, and it's interesting. Have you guys heard about? It's sometimes called property testing. Yes, maybe you heard of this.
Sorry, what kind of testing?
Property testing or generative tests. So you provide the generator, and then you have some rule or you have some rule which tests some general invariants. So for example, if you create some resource, you will get some answer, but it can be smarter. So it's always problem to formulate these properties. It's come from the Haskell and Erlang world, from mission critical systems, but they can do very interesting stuff. So the generative tests is the first topic, and another topic is performance tests. We still miss this suite. So
yeah, that's actually something we've thought about with Touchdown as a platform. We internally have done some stress testing. So I actually stood up, trying to remember how many instances, 20 instances of Wildfire with our internal version of, and basically just started running, groups of tests after tests, and just so stress testing not only Touchdown, our platform, but also the FHIR servers. And, how much can this thing push out and accept? So we want to stress test Touchdown, as a platform, but also have that ability to do it to the FHIR servers as well too. So just, banks and banks of just go, hit, and just see how they respond. But that's something we've actually thought about in terms of an offering in our roadmap. Start thinking about load testing and stress testing.
Yeah, and we haven't really explored that in Inferno. We looked at it briefly back in the Crucible days, but it's a matter of just kind of had to focus on something, and so we've really focused more on the interoperability aspects. There's just a lot of sort of challenges that we could think of in order to be able to kind of compare apples to apples to apples, right? Apples and oranges, depending on the sort of the how whatever test system was deployed. But I certainly think it's an interesting aspect, and I think sort of broadly, there's another project in that MITRE is working with ONC on called Lantern, which is looking at live endpoints, and they just sort of passively check out the capability statement to sort of take a look at and basically monitor response times and whatnot, because there is obviously there's more than just when you're working with API endpoints from a quality perspective. It's more than just are they giving you the right format and the right data. It's from a practical perspective, if they take 10 seconds to respond, they're not going to be necessarily a very useful API, or if they go down a lot, right? So
what's the uptime?
Yeah, that kind of stuff.
Yeah.
Like more operational sort of stuff.
Yeah, I mean, one of the aspects of that is you want to invoke these operations, but not necessarily all of the testing, all the asserts. So you want to do the actual capture of the operation request response, but then maybe delay the actual testing of all of that until after the fact. So that way you can just simply focus on, here's the performance, here's what the response times that I'm getting for these operations. But since we're capturing all that information, we can actually go back and after the fact, apply the asserts to the operations, perhaps, take those test scripts and say, well, ignore the asserts on this run, but now go back and reapply them to evaluate on a per operational basis or something like that. So yeah, a lot of things you can do, but time and resources, you got to focus on certain things, so I hear you, Rob.
Yeah, I think another problem or challenge we can discuss that. So for the tests, you usually want kind of the controllable environment. Yes, you want to load some fixed data. So to test, for example, some searches, yes, some paging and all this stuff. And I think that's still missed part from the FHIR servers, and maybe probably wrong direction when we start testing public servers. Yes, looks like there should be server per test suite or some approach to do this. I don't know how you fight with this situation.
Trying to find the mute button. I don't know. There's a couple different approaches you could probably take, but one is, like with US Core, Rob, you mentioned, it's like they're read-only. So there's no write capability in that particular IG. So to test that IG, you have to have a predefined set of test data that you can utilize. So, I think of Cynthia, get this nice huge data set. And I think there are some organizations who have done that. They've actually generated a Cynthia data set that is, here's our test data for what we want to test. And so load this into your FHIR server or into your system with your FHIR front end so that we know what you have in terms of data so that I can do apples to apples comparison. FHIR server A and B all have the same test data so that I can run the same set of tests and compare them. So that's one major approach that I think is something that people are already doing to some degree. But yeah, the challenge is I don't know what data you have. How do I write a test generically that will confirm what you have is good when I go to another server and they've got a completely different data set? And how do I run the same suite of tests to do that similar comparison, to verify, hey, you're doing it right, and how do I do that reliably? So that there are challenges there, yes.
Yeah, looks like the test script should have a control over data, like clear everything, load specific data set, because good reload the data set, but it's only for read-only tests. Yes, when you start executing some workflows, which are not only read, but some creates, update, deletes, you will change this data set. So somebody have to reload it again, or you have to fix, restore this data.
Yeah, I do have an example from our Nictus client. So they're doing tons of test script authoring, but one thing that they do is they have what they call their load test script. So the test script is designed just simply to, via transaction bundle or via a series of creates and updates, pre-stage the data. So you run that test script first, and that stages all the data, and assuming the server supports write operations. And then you start in with your bank of other tests that follow, knowing that you've got that data in place.
Okay.
And they're able to state that write is required for that load process, or not necessarily? Like if they happen to. Yeah.
So for the MedMe IGs, that the Netherlands has, write is part of it. So they're able to leverage that, fortunately. So they, you have to support a transaction or a batch bundle. You have to support create, So yeah, for in that environment it works because that's part of the implementation guide.
Yeah, that's I mean, that's when we were writing our US core test, I was like, yeah, I mean, it would have been a lot easier if they supported right. But yeah, it's read only. I mean, how we handle it in this case, and it's not the only way, is that we basically defined a what we have to see, sort of a certain number of features we have to see of the data in order to say that they've sent us enough for us to know that they can support everything they need to support. And so instead of generating, well, we do have a test data set that they can use if they want. But in general, instead of sort of ahead of time defining, sort of creating a data set and giving to them that conforms to those rules, we just sort of more generically think of what are those rules. And then when they send the data back, we look at all of it and say, okay, well, you've sent enough that it sort of meets all the requirements. That's, it's very specific to this US core case. It doesn't necessarily have to be the only way to sort of handle the data aspects of it. I think, I think just realistically, there's, you have to, you can always do more testing and more thorough testing. And definitely coming from, software engineering background, I want to, like, and I'm testing my own stuff, right? I have very specific fixtures that I, load up, and I have a very clean environment. For these kind of API tests to sort of, sort of accept the fact that it might not be quite as thorough, and sort of, but try to be upfront about like what we can test and what we can't test, sort of given realities of the situation.
Yeah, I mean, that's why you have manual review of certain tests. Yeah, there are just some things that you can't automate completely, right?
Yeah, and I think I am sort of interested in how all this progresses, and if there are more sort of multi-purpose FHIR servers that are used broadly instead of. So right now, I think a lot of the kind of earlier adopters, at least here in the US, are kind of more facades on existing non-FHIR kind of systems. So a lot of the data is coming in through other means, right? Through user interfaces and whatnot, and then get sort of mapped into FHIR. And so you can't sort of necessarily trust that like a write to a system is really going through their kind of normal kind of workflow, right? But maybe over time, as FHIR gets more adopted, more and more systems will be sort of use FHIR servers as kind of a more central store. They're more central to kind of the whole workflow, and you get more assurance that if you're just testing that sort of the FHIR API, you're actually testing kind of the full system.
Yeah. It would be nice to have these standard tests with maybe some additional requirements. So you should support bulk load and write operations. And if your server support, then we can run autonomous tests without any preparation from your side. Just put your credentials and base URL, and we will fill you with data. We will test all operations. So that's part which we missed. So we can run our FHIR server as a Docker in a CI. So that's usually how we do this. So and we support even operation like Yana showed, like access to the database. So you can just truncate the table before the test and fill it with the data. But probably other servers may support some alternative versions for that. So that's, I don't know.
Yeah, for Wildfire, I actually did an extended operation called Purge, which is, it's like the patient everything, but in reverse, right? It's like, give me a patient ID and wipe that patient out, from the database and all of its related data. So, and that's actually what Nictus is using. They leverage Wildfire as one of their RIs. So their test script to load data will actually do a purge operation first, and then load the data, to make sure it's completely clean.
Yeah, it sounds like that's something that could be put in like an implementation guide, right? It's like if you support that implementation guide, it makes it easier to test, right? These support test harnesses, so that like you don't have to in order to be conformant to whatever you're really testing against, but it just means that you don't have to have somebody, somebody typing in, test data, right? And so that's really incentive, which is, I think that'd be a cool thing to explore.
It may be called testable FHIR server IG. Yes.
I like it.
All right, let's wrap it up. If somebody missed it, like let's call it again. So May 17, 19th, going to be FHIR Connectathon, so we can continue this conversation. And there will be a lot of others at the Connectathon, so please sign up. It's still a virtual experience and much cheaper than it was face-to-face. So everybody please join. Also, I want to remind, yes, please submit your topics. Like if you want to present, we will have your presentation. So reach out to us if you have questions. The presentations, slides, recordings of this session will be posted to YouTube and our site, and everybody will receive a link. And again, thank you so much for participating, for attending, for presenting, and hope to see you very soon. Yeah, we went a bit over time, but I think it was great. Thank you so much, and bye.
All right.
Thanks,
Thank you.
everyone.
Thank you.
Thank you. Bye.
Bye bye.